Hey guys, welcome back to section 10.3. We're going to be doing just a few examples with the ellipse, and all of the equations for this for the conics are going to look like this. All right, so you have to, if you have an x squared and a y squared, then you are no longer dealing with parabolas. So that's one good thing. So if you have an x squared and a y squared, but now that's going to open up the door for circles, it's going to open up the door for ellipses, and then for the next section is hyperbolas. So what you need to do is we need to just go ahead and separate them. So what I'm going to do is I'm going to separate the x's, and then I'm going to separate the y's, and all the constants I'm just going to move them over to the right hand side. So to begin, I'm going to put the x's together, and then I'm just going to leave some space here, and I'm going to change color, and I'm going to put the y's together like this. Leave some space there, and that is equal to, I'm going to go ahead and just move the constant over to -9. All right. So the reason I left some space there is because we need to complete the square twice. All right, so we're going to do it 2 times. So recall, in order for you to complete the square, you must have a coefficient of 1 in front of the x squared, which in this case we do. So now what do we need to add here so that we have a perfect square? Well, you take the coefficient that's in front of the x, you divide that by 2, that's going to be 3. And then we square it, which we're going to get 9. All right, so we have we need to have a 9 in order for us to have a perfect square. So we're going to go ahead and just add 9 and then subtract 9 to maintain the equality. And now we're going to move over to the next one, which is the y. Well, you know what, let me finish off the x. So we did this whole this process down here, the completing the square, so we can group those guys together, and it's going to be x plus 3 squared, and you're going to have the -9 there. All right, so now when we move over to the y's, to the red ones, I have to make this guy a 1. So what I'm going to do is I'm just going to go ahead and factor out the 4 from the y squared and also from the y. So you're going to have 2y. And then I'm going to leave some space here. So then what happens is, what do I need to add to this, right? What do I need to add here to have a perfect square? Well, again, we take whatever's in front of the y. So in this case, it's the -2. We divide that by 2, which we get -1. Then we take that -1 and we square it, which we get 1. So we need to add a 1. But remember, if I add a 1, I must subtract the 1. All right. So then this right here inside the parentheses, super important, you don't forget that you are inside the parentheses, is going to factor nicely. So let me just write it down here. 4 parentheses, the part in yellow is going to factor nicely into y -1. It's whatever we have here, squared. And you still have that -1 inside the parentheses, right? And now this is equal to -9. So now all I have to do is go ahead and distribute what the y's are and move all the constants over to the right hand side. So I'm going to go ahead and say x plus 3 squared minus 9. Distribute this 4, so plus 4 y minus 1 squared. Distribute the 4 over there, we get minus 4 equals -9. So I go ahead and I add 9 and I add 4 to both sides. So then I end up with the following. I end up with x plus 3 squared plus 4 y minus 1 squared equal to 4. All right. So we're almost there. It almost looks like the standard form for an ellipse. The only thing we need to do here is the following. which you're going to take this over to hyperbolas in the next section, which is whatever you are left with as a constant, it must always be equal to 1. So we're going to divide everything by 4. So divide this by 4, divide this by 4, and this becomes 1, right? This becomes 1. So then our ellipse looks like this: x plus 3 squared over 4 plus y minus 1 squared over 1 equal to 1. Okay, now from here we can extract all the information that we had on the table, which is what is the major axis, where is this going to open up, is it going to open vertically, is it going to be horizontally, what is the center, okay, and then what is the location of the foci. So in this case we know 4 is greater than 1. Moreover, this 4 is 2 squared and this 1 is 1 squared, so right off the bat we know a equals 2 and b equals 1. So this is going to open more on the x-axis, right, because we're on the x, so it's going to be horizontal. So let me go ahead and draw the x's here. And then one more thing that I need to find is the c value, right? So we can calculate the eccentricity, and so we can also find the coordinates for the foci. All right. So real quick, how do we calculate the c value? Well, remember it was c squared equals a squared minus b squared. So c squared equals 4 minus 1. So c is the square root of 3. So you're going to move from the center square root of 3 units to the left and to the right to find the foci. All right. So how do we find the center? Well, remember the center is h comma k, which in this case the center is going to be h, which is -3, and k is going to be 1, so it's going to be -3 and 1. So here's the center of my ellipse. So now all I got to do for my foci, right, is because I know it opens vertically, right, so my major axis is going to be here, right, on that line, which we know y will always be -1. So y will always be -1. So it's the x that's going to change, where we're going to be moving left and right for the foci by a factor of square root of 3. So it's going to be -3 plus or minus the square root of 3. And that is the, these are the coordinates for the foci. So square root of 3 is about 1.7. So -3 plus 1.7, it's going to be somewhere here, still on this side. And obviously it's going to stay here. Not going to go over the x-axis. It's still going to be negative. So something like that, that's where our foci is. Focus 1, focus 2. And then we can definitely find the vertices. So I'm going to have to move a units on C. So C is here. C is here. So I'm going to move a units, or 2 units to the right, 2 units to the left. So I obviously drew this not to scale, having some scale there. So let me move the A first, 2 units. So this is where the A is, and then 2 units this way. That's where the vertices are, and then 1 unit up, and then 1 unit down. So it's gonna look something like this. And then let me go back and put the foci, which is gonna be very close to these vertices. And that is how we graph the ellipse. So the eccentricity is going to be c over a, which we have square root of 3 over 2. All right, so it is definitely going to be closer to 1 because the foci is closer to the vertice edges. So this is the actual graph for that problem that we just did. As you can see, the foci are very close to the vertices on the major axes. The next example, I'm going to work it out, and then I'll just go over the steps and also show you the graph, as I am impressed with the time on this recording. All right, so for this example, we have the following expression. So right here. So again, just like I did earlier, I'm going to go ahead and group the x's, and then group the y's, and then complete the square for each one. Again, I want to make sure that my leading coefficient is 1. So I went ahead and factored out the 4. Then I had to add 1 and subtract 1 because of the 2. 2 divided by 2 is 1. 1 squared is 1. And then I'm going to continue with the x's. It turns out that when we complete the square, when we group these guys, that's a perfect square. So we have x minus 1 squared. And we still have that minus 1. So when I hit it, distributed to 4. So I have 4 times x minus 1 squared. And then minus 4 after the distribution. So then on the next one, what we have is a 1 in front of the y squared. So we go ahead and we take the 4 divided by 2. So we get 2. And then we go ahead and we square that, so we get 4. So that's why we add and subtract the 4. And again, it turns out that these guys right here are the perfect square that we need. So it factors nicely into y plus 2 squared. And we still have that minus 4. I went ahead and moved the 4's over, so I have 16 on the side. And the last thing that we do is we go ahead and we divide by 16 to get this 1. And in that process, this 4 goes away, which leaves us with the 4 on the bottom and the 16 on the other one. So because the 16 is greater than 4 and the 16 is under the y, this thing's going to open more vertically, up and down. So then the last thing we need to do is to find c, which I wrote c squared here, which is not true. We need to find c by using this formula. So then we get c is equal to the square root of 12, which is 2 square root of 3. So now that we have c, we have a, we have b from the equation, we can find the center with hk, which is 1, negative 2. The foci, because it's going to be a major axis that is vertical, that means the y values are going to be changing. So that's why we have 1, negative 2 plus c, plus or minus c. And the major vertices are going to be 1, 2 plus or minus a. And the minor, because it is horizontal now, it's going to be 1 plus or minus b, negative 2. So then we put all that together, and this is our graph on the right hand side, which looks more like this guy right here. Okay. I hope these 2 examples helped you guys out. If you have any questions, please don't be afraid to reach out. I'm available on Remind. I'm available on the Google Classroom or via email. All right, you guys take care. Have a good day.